Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This time I'll talk about some more PCB failures, LEDs running at extremely low currents, my entry for the IFComp, disassembly of a toaster, my entry for the Retro Challenge, and some upcoming events. Hello and welcome back. First of all, if you would like to send feedback to the podcast, you can do so by leaving a comment on the podcast.cba.si page, or you can send email to the email address listed on that page. Last time I talked about failures in PCB design, and I think there were 76 PCBs and about half of them failed the first time when I came back from the PCB house after assembly. Now in the meanwhile, since the last episode I made 3 new PCBs, and I know one of them failed. The other 2 I didn't try yet, but statistically at least one of them should work to make for the 50% fail. Reason for failure was a footprint of a relay. I had swapped top view and bottom view, so I didn't read the datasheet correctly, and so the relay fit, sort of, but it wasn't pretty, so you could make it work, but let's fix it for the next batch. A small random fun fact, I was using RGB LEDs for a project and noticed that they would still emit light at extremely low currents of about 2 microamps, 2 or 3 microamps. It's not a whole lot of light, but it's inconvenient enough if you want it to be off, so I was quite surprised by that. And another thing, a few episodes ago I talked about do-it-yourself laser cut stencils out of removable sticker label sheet. That works quite well for small PCBs, but now I notice that for bigger PCBs, for example the baseboard of my CPU project, which is approximately 17 centimeter diameter circle, it doesn't really work because you have to pull quite hard on the label, on the stencil reel to remove it. So chances are that you rip it or stretch it enough or to smear the solder paste. Still worked out fine, no problems, but I see limits of this technique. So it's best used for small PCBs, I think. It's 31st of March today, and actually tomorrow the Retro Challenge will start. I'll leave a URL in the show notes. And I cannot say a lot about my project because it's sitting there and it's the same state as it was half a year ago. It's a Commodore 64 cartridge adapter. So tomorrow it will officially start, so then I can do stuff, and hopefully each episode you will hear a little bit about what I did. And part of the challenge is to keep a blog, and document what you did and describe it with pictures and text and so on, so other people could enjoy what you're doing. So that's part of the whole deal. So hopefully you'll see a lot of that in the upcoming episodes. And it lasts the whole of April, I think. So hopefully start of May you'll see it working. So another upcoming event, I think I talked about a few times already, is the IFComp, which is the interactive fiction competition. And the idea is there that contestants typically write a text mode adventure, an interactive fiction game, and there is a jury that will play for up to 2 hours, and they will judge games and then give grades, and then someone wins, and there's probably a prize, but it's more about joining the competition than actually winning something, at least on me, because I'm not going to win anything, it's just for fun for me. So I thought it would be cool, instead of writing a text mode adventure, classic text mode adventure, to use something else involving hardware and electronics as well. So what I was planning on doing was making something out of such a retro compact cassette tape adapter. You have things that look like a tape but actually are just an enclosure with gears in them, and a cable comes out of it with a 3.5mm jack plug. You can put the cassette shaped thing into your car cassette player and the jack plug into your phone, for example, and you can hear on your car stereo what your phone is outputting. Now my idea was to cut off the wire basically and make a cassette tape that you can put in an actual tape player, and the cassette tape would tell you the context of the game, so the environment, for example where you are, what's going on, what you can do. You can interact with the game using fast forward, rewind, play and stop. And the cassette senses which buttons you pressed or what you did by 2 reed switches mounted to the tape enclosure, and 1 magnet mounting to a gear inside the tape which goes round when you fast forward or rewind or play it. So it's basically a do-it-yourself encoder, and by using some intelligence you can know inside the software which is inside the tape enclosure, what's going on, so what the user pressed. To do this, I opened up such a tape adapter, measured the available area a bit, and drew some battery, like a 3.6 volt lithium battery, microcontroller, a DAC, some flash memory, and a charger chip. And it would actually fit. I think you have a lot of more space if you really want to. You can also use the underside of the PCB. I would like to make a small PCB instead of a bunch of wires, because in the end that would be faster and easier, I think. So it's basically an intelligent tape. So instead of an actual tape reel, you would have a magnetic element which you can drive from software plus an amplifier, and it would act instead of a tape reel. So you have an interactive cassette tape. That's the whole idea. Now here are some choices that I made. I would like to have it standalone without any cables coming out of it, so it would have to have some sort of battery. Now you can have a rechargeable battery or non-rechargeable battery. I chose a rechargeable battery because I did that in a previous project, and I know pretty much how it would work, and also it's much easier to be able to charge it. For flash memory, the choice was to have an actual IC, a flash chip on the PCB, or to use something like an SD card, which is nice. Except if you use an SD card, it would only make sense if you can put software on it from the PC, which would mean you would have to have some sort of file system on there, and software inside the tape, so the microcontroller software would have to be able to read the file system, and it would mean a little bit of more work and a little bit more complexity, so I chose not to do that. Instead, you would have a USB connection to the PC, which also acts as a charge port, so you can charge the rechargeable battery using the USB plug, and it also acts like a serial link, so you can upload images and interact with the game and debug it and so on. For microcontroller, I'm planning on using a fairly simple microcontroller. Doesn't have to do a lot. Read from flash and basically send it to a DAC and send it to an amplifier to drive the magnetic element to generate sound, which the tape player can then pick up. Microcontroller will probably be an Mega 48 or 88. That's easy enough. For the DAC, I thought about using an R2R DAC, which is pretty simple. You can drive it very fast because one update is basically one write. You write one byte and you output a new sample, while compared to a serial DAC, for example an SPI DAC, you have to clock bits into it, so theoretically it would be a little bit slower and a little bit more complex. But if you design an R2R DAC, you would have to choose a number of bits beforehand, basically, or you can leave off resistors, but let's say you have to know the number of bits beforehand. Now, I don't know the number of bits beforehand because I don't know exactly how it's going to sound and how samples are going to sound, how 5-bit samples or 4-bit samples are going to sound. So instead of that, I'm just going to use a serial DAC, and afterwards in software I can choose to use 4 or 5 or 8 bits and stuff the rest with zeros, basically. So that's more flexible. Now, I think the IFComp is in June or something like that. I couldn't really find it on the website. I hope they update it in time. What I would like to do beforehand is to make sure I have the hardware platform that sort of works, and then during the actual time, which is I think 3 months, I'll write the software and come up with an idea. Also ask some other people about their creative ideas for a story, because there's only so much you can do with such a limited input and output, but it should be interesting anyway. Something completely different, which may or may not be boring to you, is I disassembled a toaster, an old toaster, I think from the late 70s maybe, or the mid 70s. Because the idea was to get simple household equipment from a thrift store. It's almost for free. And then just open it up, see what's inside, learn a bit from it, maybe poke a multimeter around, and then see how it works, and then toss it away and the next one. So it's a little bit relaxing to take stuff apart. That's what I noticed. So this time it was a toaster. That was the first thing I got. So this was an old one, and I wondered if there was a timer circuit inside with actual electronics or a mechanical timer. And in this case it was a mechanical timer. Now, basically how it works is it's a small tabletop toaster, so you put slices of bread in. This is not going to be a very interesting story, but anyway. Put slices of bread in, you put the lever down, the bread goes in between heating elements, the bread heats up, it becomes brown, and when it's time to eject the bread, the lever goes up and the toaster turns off. That's the whole idea. So to do that, the lever is pushed down. The lever has a hook, which hooks behind a bimetal strip, And when you push it down, you also mechanically make contact. You close a contact so the heating element goes on and the bread is toasted. Parallel to that, another heating element is powered on, which only heats the bimetal strip, which then bends, and when it's bent all the way to one side, it releases the hook, and the lever goes up and the bread is ejected basically. So downside of this, of course, is that the time the bread will toast, the bread toast time, is dependent on how hot the toaster is when you push the lever down. So I did some measurements. So temperature of the bread heating element at a maximum is about 180 degrees Celsius. The temperature of the bimetal strip heater is about 314 degrees at maximum. If you start it cold, it would take about 1 minute 10 seconds to heat your bread. If you start it hot, it would take about 15 seconds to heat your bread, and then the bread ejects, so that's completely useless then. To cool down from hot to 50 degrees Celsius would take about 5.5 minutes. And when you start it again afterwards, the bread heat time is about 1 minute 4 seconds, which means that you can basically toast bread properly, then wait 5.5 minutes, toast bread, wait 5.5 minutes, or let's say 6, and then so that's about one piece of bread you can do every 6 or 7 minutes. It was a 950 watt device. I think it was rated 900 to 1000 watts, and if you measure the bread heating element, is indeed 56 ohms, which would amount to about 950 watts. So that's what I did. Open it up, see how it worked, toss it away, and that's it. If you're really interested, you can see a little circuit of how it works. Now, there's a green wire drawn in there on the podcast.cba.si page. I don't know why it's there. It doesn't really make sense. So if you know, send me some comment or feedback, for example. So that was that. 2 upcoming events are the Outline Demo Party in the Netherlands, which takes place at from 10 to 13 May, which is pretty close by. And I was thinking about entering something, going there and entering a small demo, because I've never been to a real demo party, or a big one at least. So the most appropriate thing would seem to be a 128 byte demo entry or intro entry. So that means there's a lot of puzzle work, but probably less work than doing an actual demo. But I'm not going to do anything. I don't want to show up empty-handed there, so I'm not going there at all. So maybe next year, if someone else wants to join in, or someone else wants to make something with me, then yes. Or if I have enough time to make something myself, then sure, why not? But this year I'm not going there. Also, I think last time, or the time before that, I talked about a hackerspace in Eindhoven, upcoming hackerspace. There was a meeting back then. I was planning on going there. I didn't go there for some reasons. There's another one in April, I think, so another chance. So let's go there sometime. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye. It's about a 900 watt device. This is pretty boring.